right, we are picking up on 10-4. This is part 3. So this will be example 8. We've done part 1. Part 1 we looked at what was less than. What will give you what's less than? The z-score table gives you what's less than. Part 2 we looked at what was more than. So we used the z-score table, and then depending on if it's probability or percentage, we subtracted from, if it's probability, we subtracted from 1. If it was percentage, we subtracted from 100 to get what's more than.
Wait, it's probabilities.
Okay. So let's look at what part 3 says, okay? So this will be kind of a review from what we did yesterday to begin with. It says the lifespan of a certain tread of tires are normally distributed with a mean of 31,066 miles and a standard deviation of 1,644 miles. Can you draw a bell curve? Yes. All right, let's do that. I want to find the percent of tires that will last more than 35,000 miles. So you can go ahead and do part A because that's a review of what we did yesterday. So why don't you go ahead and do part A. So let me record. So if you look at part A, let me just recap real quick for those listening. If you look at part A, we marked 35,000. We went ahead and made it into a Z table. We got a Z of 2.39. We read our Z table. We got 99.16%, but that is on the left side. So to get what's more than that, you subtract it from 100, and we got 0. My percentages don't look very pretty, 84%. Okay? So today's question, and this is like the extent of it, guys. Like, we're almost finished. Basically, they're going to ask you 3 different ways to ask the question. Okay? They're going to ask you less than. What will give you less than? The table. Then they're going to ask you more than. What will give you more than? The table minus, or 100 minus the table, right? That'll give you the other side. The last question is they're going to say, what's the percent between? Okay? Let me ask you this. Okay?
I know how to do it. If I can. So, it says 5% of the tires that will be 30,000 and 32,000 miles.
Mm-hmm.
So did you go 30,000? And would you like shade it that way? 32,000 and shade the other way?
No, almost. Because we want what's between. I'm going to, well, yeah. So you're going to shade opposite from each other. Yeah, you're right on that. But the question is how do you figure out the percent? So answer me this first. I'm going to put it in simple terms first. Okay? If you know from this point all the way over is 10.
Okay.
And you know from this point all the way over is 7. My question is, what if I wanted to know what was between the 2 points? What would it be? It'd be 3. Because you get it, so you find 1, you with me, and gives it to you to the left. You find the other, gives it to you to the left, and if you take those 2 and subtract them, you'll get what's between. So if I was doing this problem, let me just explain. Let me explain so I don't confuse you. Okay? If I was doing this problem, if I marked 30,000, that would be somewhere right here. You with me? Okay? So let's just say that this would be, I don't know, 40%. You know, from everything, from there over would be 40%. And then I'm going to mark 32,000, which would be this. Let's just say from here all the way over is 60%.
Okay.
So my question is, I want what's between. So what would be between? 20%. You just take the 2 and change it.
Yeah.
But we don't know if that's what it's going to be.
Yeah, they're not really,
Right. So listen. we're going to do what we've normally been doing. I want you to take 30,000 and I want you to find the percent to the left. Okay? So make it into a z-score and go to your table. Okay? So we're going to take z equals 30 minus, what's the mean first? 31,066 divided by 1644. So do that for me first. Round it to the nearest hundredth.
Got it.
And then we find it.
All right, so what's the z-score?
Negative
Negative 0.64.
Negative 0.6.
Here, I got it.
So it goes 648.
Yeah, so 6, 5.
So does the 8 make the 4 go up?
Yeah.
Yes, so it'd be 6, 5. Okay, so go to your z-table, go down to negative 0.6, and go over to the 5. And give me the percentage. What percentage would it be?
0.2611.
You're doing you went over to 4, not 5.
Alright, so let me go fix that. 0.257.
So go ahead and make it a percentage. Okay. 25.78%. So that's this right here. 25.78%. You with me so far? And I'm not rounding right now because when do you round on a problem?
And your answer.
At the end. Okay, we're not done. So now we're going to go to the other spot. So we're going to go to 32,000 and we're going to find our z-score. So minus 31,066 divided by 1644. Find me the z-score of that. 32,000 minus 3166 divided by 1644.
1,044. Divided by
0.56.
I hear 1 for 0.57.
Yeah.
Do we agree? 0.57. Are you with me so far? They got 0.56. 8.
0.57.
So it rounds it.
It's 0.56.
Is that not what you got, Jasmine?
So that means
All right. Here we go. Let's go down to 0.5 and go across to 7 and give me the percentage.
71.57.
All right. So this is 71.57%. So here's the whole thing from here over is 71.57%. From this piece over is 25.78%. So how can I figure out what the missing piece is? So you can just take the two, you find both percentages, you just take them and subtract them.
45.79. Wait, someone check that.
So this would come out to be
40.79.
40.79%. Okay? Any questions on, you're just going to find both and subtract the two to find what's between. It depends on what they ask you. Like if they say round to the nearest tenth, does that make sense? Then you would say 45.8%. If they say round to the nearest whole percentage, you would say 46%. Okay? But here's where I round because I'm at the end of my problem.
Is that a 9 after the 7 or a percent?
That's a 9 and then a percent. All right. So I want you to try this one on your own.
Pretty easy.
these should be pretty easy. It has a mean of 68, a standard deviation of 10, and I want to know the percentage that they would weigh between 50 and 75 pounds. So this would be 68, and then we're deviating by 10, so this would be 78, 88, 98, 58, 48, 38. Okay, and I'm going to mark 50. So here would be 50. And then I'm going to mark 75. So here would be 75. And I want to know what's between. So you're going to set up two problems, one for 50, one for 75. Find your percentages using your table, and then subtract them. All right, I'm going to hit pause now. All right, so I have found the z-scores for both. We're going to go to our z-table, and I'm going to look at negative 1.8. Okay, so negative 1.8. So 0.0359, so that would be 3.59%. This way, to the left. And then I'm going to mark this. I'm going to go to 0.7. So it would be 75.8. So this would be 75.8%. And then my question is, if the whole thing is 75.8 and this little piece is 3.5, how can I figure out what's between? Subtract them and you get 72.21%. 21%. Okay, any questions on to figure out what's between? You subtract them. You just find both, subtract them. Okay. Probably like maybe Tuesday. All right. So this one has 3 questions. Okay. If you take a statistics class in college, this is how they're going to ask you. Okay. It says, and basically this is just fancy notation. This says find the probability that X is what? What does that say first? Less than. So this one would be less than. So here's my question. Just because this is given to us slightly different, can you use your mean, use your standard deviation, and find the probability that it's less than 17? And then here, this says find the probability that it is greater than 22, which means you're just going to subtract from 1. Okay, to find it on the other side. This is kind of recapping all 3 ways. And then this is asking, find the probability that X is what? Between 17 and 22, which you will be just fine because you're already going to find 17 and 22 for that one. Okay, so find me the probability that it's less than 17. Find me the probability that it's greater than 22. And find me the probability that it's between.
Wow.
It's just saying that it could be between, that X could be between those numbers. That your data value could be between. You don't have to solve for X. You're just finding the same questions. All right. So if I did 17 minus 20 divided by 5, what would the z-score be for this one?
0.6.
Negative 0.6? Okay. And so I'm just going to draw the bell curve in the middle for each one. I hope you drew a bell curve because that will help you make sense of where you're going to shade. So this would be 20, 25, 30, 35, 15, 10, and 5. Okay, so if I mark 17, which would be here, and I want what's less than. Okay, so here's my question. What's the percentage less than, or the probability less than? 0.27, 0.43. So 0.2743. Okay, and so that would be your probability, 0.2743. And we don't need to do any more because that's less than the table.
Take it out of 1.
Nope,
Wow.
because that would be if we wanted the other side of it.
Sorry, never mind.
Okay, all right, then I'm going to mark 22. And if I did 22 minus 20 divided by 5, I would get 0.4, right? And this time I want what's greater than. Okay, so if I used my table, 0.4, what would be the probability according to our table? So 0.4 would be 0.6554. But my question is, where is 0.6554? 0.6554. That's this side of the chart. So my question is, how do you get what's greater than? 1 minus 0.6554, which would be?
0.3446.
0.3446. Okay, how many have gotten them both right so far?
I got the one right.
Any questions on that?
That's if you want. That's if you're doing probability and you want greater than.
Right. Okay.
Okay, I got to. Oh, never mind. I got it.
Okay, so now the question says what's between these same 2 points. So now I want this area. Okay, so you know from here over is 0.2743. And you know from here over is 0.6554. So how do you get what's between? Subtract those two. So what would it be?
Oh, so I had it right the first.
Point what?
0.70.
No,
No, that's for what you.
that's on this side. Greater than. I'm using the less than. So you need to subtract 0.6554 and 0.2743. 3811.
Because it wants less. Because it has 2 less than. Sorry. Okay, yeah.
Well, this is just saying x is greater than this, but less than that. So it's between them.
What's your 0.6554?
Because from here over, we knew the z-score was 0.04. And when you use your table, from here over is 0.6554. Okay, and from here over is 0.2743. So you take these two right here and subtract them to get the missing piece. If the whole thing, listen to me, okay, if the whole thing is 65%, you with me? That big piece is 65%, and this piece is 27%, why can you find the missing piece? Just subtract them.
I mean, I get everything, right? But I still.
The only reason I had this point, how many took the 0.3446 and subtracted it accidentally? Okay, that's only if you wanted that side of it. Okay, this was a completely separate problem using the same numbers. That was for the second one. You don't do anything with it. That was just the answer to the second one. That was on this side of it. Okay. Does anybody know another way to figure this out? Well, let me ask you this. Everybody listen. One other way you could actually figure this out, the whole thing's out of 1, correct? You knew this piece in red was 0.2743. You know this piece in red is 0.3446. And the whole thing's out of 1. So what could you do to figure out the missing piece? Everybody listen. You could just add this and subtract it from 1. Do you understand? If you knew this was 27% and this is 34%, could you not just add this and then subtract it from 1 or 100 if you're doing percentages and get the missing piece? You could have done that. All right.